With raindrop-driven erosion, transport mechanisms vary with flow conditions. And because flow conditions vary along an eroding surface, the spatial distribution of the detachment and transport mechanisms vary along an eroding surface. Generally, these different situations depicted here depend on rainfall intensity, slope gradient and slope length, and time, and the temporal and spatial variation in transport mechanisms control how soil loss varies during an experiment. In many experiments, splash erosion occurs at the beginning of an event to generate detached material that is subsequently transported by rain-impacted flows by raindrop-induced siltation and rolling. Particles transported by raindrop-induced siltation and rolling travel at various rates over the surface and take time to move down over the slope. There are cases where flow-driven siltation and rolling control the movement of particles passing over the downstream boundary. Here we have a situation where flow-driven siltation controls sediment discharge over the downstream boundary, while upstream there's a zone of raindrop-induced siltation. Any drop impacts in that bottom zone will cause sediment to be discharged, while raindrop-induced siltation moves material downslope in that upslopes area. However, any material that moves from that raindrop-induced siltation into that flow-driven siltation zone will be discharged. In effect, this causes X for the raindrop-induced siltations to be increased. Other particles of different size and density can still travel over the downstream boundary by raindrop-induced siltation. Consequently, both raindrop-induced siltation and flow-driven siltation can operate together to control sediment discharge. So we have situations C and D occurring at the same time. This is a model of raindrop-induced siltation, where the distance particles travel varies with particle size, density, flow depth and velocity. And in this graph we have flow velocity at the bottom of a 2-meter long slope, and the critical velocities for flow-driven siltation of 0.46 mm coal and 0.1 mm sand. When slope gradient exceeds 30%, flow-driven siltation moves coal particles across the downstream boundary. As the area of flow-driven siltation increases, so too does the discharge of that coal material. However, particles of sand still are transported across the downstream boundary by raindrop-induced siltation.